Welcome everyone to this week's IPLD Dev Sync meeting. It's September the 21st, 2020. And as every week, we go over the stuff that we've worked on in the past week and then discuss any open issues we might have. Please put your name on the attendees list on the HackPad. By the way, the HackPad is online again because there was some maintenance work, but it should work again. Yeah, so I start with myself. Not that much to report. I'm still on the Rust multi-hash stuff. Interesting thing was that while I was improving the API, because when I was integrating it into Rust CID, it was just API-wise horrible to use because you constantly need to unwrap things because there might be errors. But in many cases, you were 100% sure there won't be an error, but you still have to unwrap because theoretically there could be one, but not in those cases. So this led to a few API changes, making things a bit nicer. And then kind of like, I changed almost everything. I kind of rewrote the whole thing, but now it's again back to what it used to be, more or less, which is good. So there's not too many changes when I do a PR. But I think I'm happy with the result. I'm still making sure that everything works. And then also again, trying to integrate it with Rust CID and libp2p, because like this is kind of like my libraries I use to make sure that the API is at least kind of sane. Yeah, cool. Yeah, there's not much else I did on the IPLD side of things. Next on my list is Danielle.
Cool. So I continued with the IPLD ADL for HAMT. I had a helpful call with Rod and Peter to essentially discuss any questions I had about HAMs in general, and especially the schema for the one we're trying to build here. So I'm still making progress on that. Now I've gotten to a point where I actually understand all that I need to write, because before I wasn't familiar with how Go IPLD Prime works or how ADLs are actually implemented. I also wrote the first half of the introduction to IPLD in Go, which was part of the doc week. There's just a little section left as a to-do, so I'll finish that up this week. I also dug myself into a rabbit hole for multi-codec because I found that the examples for IPLD Prime, when they, for example, use DAC-CBOR, they would just use 0x71 instead of doing something like multicodec.dac-CBOR or apld.dac-CBOR or something like that. So I think I'll be code generating a light Go package with constants for all of those IDs at least. And finally, with Eric, we started writing down ideas of how we could change Go IPLD Prime's API in the near future, once things with Filecoin calm down a little bit. Things like the import paths that don't depend on GitHub, but also some other things like removing some unnecessary error returns and stuff like that. And that's it for me.
Thanks. Next is Michael.
Hey, yeah, so I just did a ton of doc stuff, mostly cleaning up stuff, shuffling it around, writing more documentation, and then a substantial change to the specs site. So there's a new specs website. It has all of the specs and all of the content, not just schemas now. Before it was really just for schemas. And that was really necessary because I need the doc site to link to the specs quite often. So there are improvements going on in kind of both of those places. As a result, there's a few new files that landed in the specs repo without PR because they just like had to go somewhere really quickly and I had to get the site up. But so there's some cleanup still to do there. And there's still a little bit left to do on the docs website. We're waiting on Infra to click over the website. But in general, the docs website's looking pretty good. It's like showable to people. We need the Go stuff merged in. We need the Rust stuff merged in. But in general, it's looking much better than anything that we had before. So that's good. I also took on the pathing spec, so I took that off of Peter's plate, and I'm going to write that up. Working on it now. If you have any relevant docs, send them my way. I have a markdown file that him and Eric wrote a quick doc on pathing too that was in the docs repo that I moved over. So working on that. And last week I was poking at this podcast client on DagDB. At some point building this docs website, I realized that I don't know why it takes so long and there's so much code in ViewPress to make a website from Markdown files. It seems like a lot, and seems like it'd be really easy to make a website from Markdown files. So I started kind of poking at that problem and realized like, oh, there's actually something really cool that you could do here where if you take the Markdown files and you use a YAML front matter, you end up with like basically sort of display data and metadata, like actually structured data, kind of together in this unified tree structure. And then I can just take that and actually stick it in DagDB like as a data structure. And then what happens when I start playing with that? And so I realized like, oh, you can use that to like build out like a list of posts and, you know, site maps and all that kind of stuff can just be like from the DagDB representation because it can do all the linking and all the indexing. So it's basically like I started working on this little project that basically takes, you know, a repo of Markdown with YAML front matter optionally and turns that into data structures. And then another thing that takes those data structures and turns them into this website. And then also I was like, oh, but you could follow other websites and then they could be like in your follow feed and you could start to do some of like the data, like the social networking kind of interlinking stuff. So I've been poking at this, been calling it IPMD because it's really just sort of like Markdown plus YAML front matter as like a data structure that's like a website that you move around, but it's kind of cool. And it's like using a lot of the GitHub Actions stuff as like the backend for this. Like all the DagDB stuff is just stored in that. So that's how like replicating other people's databases comes around. Like all of the hosting and everything is already there. It automatically installs like an action to do the publishing and things like that. So that's been like a fun little thing to work on. It's definitely feeding a lot of stuff into DagDB and into our primitives. Like I'm realizing that there are things that like could be a little easier in all these layers that I'm like fixing as I go. But yeah, it's like a fun little project that I've been poking at. You can feel free to look at. I think that by the new year, everyone on the team will just have their own little personal website that they're publishing with this because it does make publishing a little website like really fun actually. Like fuck Hackpad, like I'm just gonna start pushing Markdown files to my personal website and you'll see them like because like that's actually easier. And like some of the workflows are like easier than some of these like websites that we use for that. So like I probably won't use GIST anymore. I'll just like make those pages on my personal website. It'll be fun. Anyway, I don't know who's next. Eric.
Me. Yeah, that sounds great, by the way, because I spent a little time poking around at trying to renovate my personal website this week. My current one is, I don't know where. I actually don't know where. It's like decades out of date. And it, like all of the modern tools. Anyway, so in IPLD Golang news, so as Danielle's been writing some of the doc stuff, it's kicked me in the shins to try to make some of the things prettier, which has been good. And so one of the things I worked on this week is making some porcelain type functions to help you construct data that will take like normal Golang types, like maps and structs and stuff, and sort of scan over them with reflection and turn it into data model. And so that's arguably long overdue, but so there's a initial draft of some prototype of that. It's going to be a very, very inefficient thing. It will not be CPU fast and it will not be memory allocation cheap. It will in fact be laughably terrible at both of them, but it'll let you get stuff done in like one-liners. So maybe it'll have some utility. So there's a PR for that. Not quite finished. You have to handle every case and reflection. That takes some diligence. The other thing I worked on this week is I took another crack at the whole link loader story. This is something that there's also been an open issue on in the Go IPLD Prime repo for a while. It's number 55, and it's just big questions about, can this be simpler, please? And that's been a tricky subject because it drags together all of these different interfaces at once. Like we want to have codecs be separate, but all come plugged together, and the multi-hashes all be separate but come plugged together. And then all of this comes at the same junction points as the rest of the link stuff. And like, yeah, it's just a lot of things that touch. And so I think I've got another draft of something that might be a solution to this. And it breaks all of these things down into smaller function type declarations. So there's a function type for like choose the multi-hasher implementation and like choose the codec implementation. And so there's that layer of function interface, and then those give you something that conforms to the function interface of the codec. So it's not a direct binding there either. And the idea is that then we can make the whole registry system even one of those function types. That's just a chooser sort of prototype. And this should give us all the flexibility that we need to build registries that are simple and user-facing and like do the right thing by default. And it also gives us the ability to let other people make their own versions of those. So like basically if you didn't want to have a global registry, then you could use a bunch of your own functions for this. And then they all get pulled together into one big old structure called a link system. And then the idea is here we can put all of the other helper methods that a user actually cares about at the end of the day. So we have one place to repeat all of those things without pushing all of that implementation effort and tons of other helper functions into each implementation of links or codecs or hashes or anything else. So this is still just a draft, but it feels a lot simpler. And I think we might want to try it out in the future. So that's cool to have in the sleeve. That's about it for this week.
Thanks. Next is Rod.
Okay. Am I on? Yep. My week has been all about protobufs, and my head is full of protobufs. So full of protobufs. So I think I'm done. Although I see Liddell has posted an interesting issue on where has he posted this? The shipyard. Yeah, he's just posted an interesting issue on IPFS Explorer components, where the Web Explorer and also the Web UI and also the Explorer is having trouble navigating through certain Unix FS paths, and error type E is undefined, so it looks like it's coming out of IPLD tag PB, the older protobuf library. So that's something to look into. I'll have a look at that. So what have I done? So the new DAG PB library, I'm pretty sure is ready for publish. Although I would like a look at the specs link first, the pull request for the specs. Now it got simplified in the end. I bit off more than I needed to initially and then wound it back. So really the only major change to the schema is making the hash optional, which it is in the format, and it is in Go. So I decided to make that a. There's no, like it would be nice if every link actually had a hash, but it is possible to construct blocks now that don't have a hash. They just empty links, and so while that's not ideal, we should account for those blocks existing. But anyway, there's discussion on that might be worthwhile if you think that's a bad idea, and we should start blocking that out and stopping loading those blocks as being valid. So that's pull request 297 in the specs repo. In there as well, I've added a bunch of other little notes underneath the schema that clarify how additional constraints that you can't express within the schema. Things like you can't have an empty links array because that's indistinguishable at the byte level, at the block level, at the encoding level. It has to be undefined or optional or missing. So your links array has to be one or more. And there's a few other little things like that in there. Now I added some tests into Go Merkle DAG where the Go implementation lives. And that's there's a pull request in the notes. I'll try and get that merged, but that adds some tests to push at the edges of the format to see what happens in different cases, what it ends up with as binary and what it decodes as, just to see the nature of these round trips and what it means for various shapes to exist at the data model, and then what happens to them when they go through a round trip, so that we can pin down an exact form for these things. And then I've mirrored those tests in JavaScript. There's a couple of cases where I exclude the options. So one case is that I'm saying that a hash has to be a CID hash, and that a hash that can't be interpreted as CID should be invalid. And you could use the same argument for that to say, well, a hash shouldn't be undefined either. Maybe that's something we should do. And a couple of other things where, the empty links array. So you can't do that. You just can't make a thing. So one thing that the new JS implementation does is it only allows you to encode an object that is of the precise shape that it should be, and that it would end up being if it was to undergo a round trip through the encoding. So you can't make an in-memory version of these things that is invalid and that would be changed if it was to go through a round trip. So it's really strict on the checking of those objects, but it also exports a prepare method that lets you, you can run it as a safety measure or as a convenience if you were a little bit sloppy about the way you wanted to create objects. And it'll do things like it'll make sure that you don't have any extraneous properties on your objects. It'll turn strings into bytes, things like that. It'll sort your links list the right way. Stuff that is a bit tedious to take care of if you're creating complex things. Or if you're just shoving data in and you don't want to make links, you just want to shove bytes in, you don't want to have to form these things. So there's a prepare method on there to make it easier to deal with a very strict format. And I think that works quite nicely. So that's that. I think I'm wrapped up. This question about the hash maybe needs to be addressed. I'm still unsure about that. But aside from that, that's me. I think I'd like to move on from PB now. It's a little bit tedious. Oh, the other thing is in the JavaScript implementation, I wrote a hand-rolled encoder and decoder for protobus because our format really isn't that complicated. It's very simple. And so what I actually did was pull out the code gen version from Go, rewrote it into JavaScript, and then refactored and simplified it to be much more pleasant. And so it's now, there's no dependencies in that library. So it'll be able to do the whole thing for itself, which is nice.
We can probably include it in the defaults in the block interface now if it's that small too.
Yeah.
It's like the reason why we didn't include it is because of the depth tree. So
yeah.
Wait, so you used the protobuf compiler to generate the JavaScript, then you just like kind of hand whittled it down to the minimum needed?
I took so the Go version has a code gen version of a protobuf encoder decoder in it, because that's just how you do it in Go. Like you actually make the code. So I pulled that code across and then converted it into JavaScript manually, and then because it's not that complicated, and then I just simplified it out. Like all the duplication of the var-int encoding, I've just got a function to encode and decode var-ints, and that they're just not complicated. So it's all inlined. It's all in the thing. There's no dependency for var-ints or anything. And deduped things. And I added, no, what did I do? So there is this case, a really interesting case in protobufs that it will allow you to decode sloppy objects. So DAG-PB will accept objects that have extraneous data that doesn't relate to the format. And in the Go version, it just hangs it off this hidden property in the DAG-PB struct, and it's never touched. I've left that in there, and it just gets dropped on the floor at the moment. But it's one of these cases where our formats have all of these ways that you can embed. You can create blocks with the same data but different hashes, or you can hide data in there that doesn't get used. And I didn't think DAG-PB had that, but yeah, it does. So all of our formats have this in some way. So that's there, and I'm not rejecting. I'm tempted to put a throw in there so it doesn't even decode blocks that have these. But who knows how much of this stuff's in the wild? So
I would be very surprised if that was in the wild. Very surprised.
Yeah, so would I. But you never know.
You just don't know. Yeah, I looked at the code. It's pretty small, but my first thought was like, why the heck would you start with Go generate code and port it to JavaScript? The JavaScript build from Protobuf, but it's so small.
Well, we're not using like all of Protobuf either, right? Like we have like this very tiny narrow.
Yeah.
Like everything that we're using.
But it's just kind of weird. I was kind of like, dude, like what? That seems like the most inefficient way to get to where you want to go.
To be honest, this was one of those accidents. That was the yak shaving accidents. I was in the Go code and I was messing around with it, and I was testing some of the edges, and so I had my head in this code, and I was like, I want to see what this does in JavaScript, and I was porting a little bit of it, and why not just do the whole lot? And it's really not hard to convert basic Go, especially code gen Go that doesn't do too much fancy stuff, into JavaScript. It's just, it really is just changing a bit of syntax, and that's it. And then you get to refactor it into something nicer, and you end up with. And the nice thing is that it's really quite efficient in the way that it lays out the bytes, and I've managed to find what I think are some pretty good efficiency gains in the byte handling, the way it lays it out into the block, and then the way it even reads it in. It'll do some. It'll reuse bytes in a fairly efficient way. So I wouldn't be surprised if we get a pretty significant performance boost from this. But I don't really want to spend too much more time testing that kind of stuff. And yeah.
Cool. Okay, does anyone else have any updates or want to share?
I have two things real quick. So one is, someone posted some question on the IPFS Reddit today about IPLD for Bitcoin, and I provided a response. So feel free to view it. Let me know if I missed something, or a better way to do it. I just linked it in there in the chat. And then the other thing too is, while you guys are looking at that, with the JS GraphSync project, what I need is kind of like a reference of a responder and a requester with GraphSync, and I'm planning to write those in Go since there's already a library that works. Obviously, IPFS has a responder capability, so I could use that, but it's just a big dependency, so I just kind of want to do something quick and simple around Go GraphSync. And so here's my question. Given the fact that I'm building a JavaScript library, and I need to use Go-based code as to run against the verify operation, what are your guys' thoughts on how I should structure this? Should I put the Go-based code in a separate repo and pull it in as like an extern Git submodule? Should I put those Go things in some other directory in my JavaScript package or my repo? And if so, what would be the directory structure for that? I don't know if you guys know what I'm talking about. My main goal is to write JavaScript, but I need some Go code to use this verification for the JavaScript. I need to put that somewhere. So what are your guys' thoughts?
Would that be just test fixtures? Is that what you're doing?
Yeah, I mean, probably, yeah, that's all my immediate needs are. I need like a CLI to basically act as a requester against a JavaScript responder, and then vice versa, a JavaScript requester against a Go responder. So the very simple wrapper around Go GraphSync that will issue a request. I could even hard code the CID and all this kind of stuff if I wanted to.
Yeah, I've had a few occasions where I've had to do things like that, and I've had variations of either embedded as a, like I've got one repo where I've actually got JavaScript and Go mirrored side by side for publishing, but it's just on the Go side, it's not an ideal way of consuming it. And other cases where you just stick it into your test directory as a separate subdirectory, and then you could npm ignore it from your publishing. Because the nice thing about Go is that you don't end up with, you don't bloat your repo compiling it. That all happens elsewhere. So your code just sits alone, and compiling doesn't, you don't end up with tons of object files you need to clean up later. So it's just, but maybe the ideal option, if you're going to do a fair bit of it, is actually to set up a separate project and put it in your Go source directory, because one of the problems with Go is it's not happy if you don't have it set up in the right directory, in the right layout. Go source. If you don't do that, then you're in for a bad time.
You could
So that's an
also
argument for a separate project.
compile it to WASM and then call it from JavaScript. So you just do all your testing in JavaScript with Go code that's compiled to WASM.
And then you really bloat your repo.
Oh yeah, well, yeah, yeah.
Well, the only thing is that I need network connectivity. I'm not sure if does the Go WASM support, or does, I guess it'd be the Go libPDP. Does that support a WASM
No.
network
I
stack?
don't think so. You don't get full networking functionality, I think, when you compile to WASM, but you can do wrappers for algorithms, whatnot.
Yeah. Okay. So I don't know if that'll work, but so it sounds like Roger's saying either just put it into the test directory as like a test fixture or test, I guess, app, or a separate repo. Those are the two things.
Yeah, it depends on how complicated it is. If it's really simple, just make a Go directory in your test directory, stick it in there. But
that's what I was thinking, but I thought I'd check.
If there's any complexity to it, make a separate project and publish that separately, and put it in your Go source directory. Otherwise, yeah, it's pain.
Actually, what I should probably do is add it to the Go GraphSync library as like test example apps, because they're very basic. I could see anyone using this.
Yep, that's definitely a good idea. I have a few cases of that as well. Like my DAG-PP one. That's what I've just done. Is really, I'm adding tests to an old repo, and I'm not touching their code. I'm just adding tests to show me some stuff.
Okay, I'm a bug Hannah and see if I'm sure she'll be fine with it, but I'll just check with her. But that actually, now I'm thinking about, makes more sense. Thanks.
All right. Any other updates, questions, or things to discuss?
So I just have a question about encoding formats with CBOR to JSON, and I'm just curious how conformant the IPLD spec is for. There's a new draft in IETF for RFC 7049, and I think a lot of the edge cases are not relevant for my use case, but I was curious if you guys are following up with the latest draft of the IETF RFC to make sure that it actually is following the JSON serialization recommendations, which are non-normative, I should mention. Here's the link.
You cut out a little bit at the end there. Okay, so it's a new CBOR spec.
It's a new draft for updating the CBOR with, I think, as I mentioned last week, I had some challenges with converting CBOR to JSON.
So we don't follow this at all.
No.
So like so first of all, we don't
well,
actually convert CBOR to JSON. I mean, maybe Volker does somewhere.
Well, we don't, but like at least I took it sometimes as an inspiration on basically how they JSON should look like, or even like how we structure the or like basically, so no, see, at least I took this inspiration for when we're defining how the DAG CBOR works, to make sure that when we do something specific in DAG CBOR, that it also kind of like applies to when you then convert it to JSON or back. So kind of like, so basically the recommendations in this section is quite good to see how kind of like a trimmed down CBOR looks like. And so I took this inspiration when I thought about the data model and so on. So, but I don't think we really followed it closely. But if there's any updates, I think we should check it out to make sure that, yeah.
So I'm writing the update to the DID document for the CBOR section I mentioned last week. And they want me to come up with very specific guidelines for lossless conversion between CBOR and JSON, especially when it has to deal with binary representation in the CBOR, and to transform that into conversion to, let's say, base 16, base 64 encoding of that binary blob in CBOR, since that's not supported in JSON, obviously. In CBOR, there is like tags, tag 21, 22, and 23 to do this, but there is no like tag for base 58. So in addition to all that, I'm actually also recommending the public key multi-codec attribute property. And that is basically, they don't like a link, so it's not going to be a slash in the CID. It's just going to be a CID. And that CID is self-describing a multi-codec that says this is base 58 encoded. It's in version 1. It's a public key ED25519, and then the bytes follow in that encoding.
Does it make sense to use base 58 encoding in this case? Like what are your reasons to use base 58 and not like, I don't know, like just like basically, I mean, for JSON, obviously like base 64 or something, I guess would make sense.
Yeah, I think they're just making it purposely difficult and over-engineering it myself. And I think it's mostly just corporate jousting, trying to get people to basically one-up each other. And then I'm trying to make sure that it's just basically, it's easy. What I had mentioned last time is that they don't like the basically string representation. And so they have this whole convoluted naming structure of, let's say, public key hex. And that's supposed to represent, like the thing that follows it, it's supposed to be a public key hexadecimal representation of a public key that is have a particular type, et cetera. And so it's over engineering, if you ask me, but I'm trying to be conformant and give some recommendations for lossless conversion between CBOR and JSON.
Yeah. Okay. Yes. So I would just like I guess like because the base 58 is kind of a pain, at least from my experience, that you basically, so there's not that many like for base 64 there are so many encoders out there, so it's super straightforward. But yeah, I would probably use base 64 or 32. But yeah.
Yeah. But they want to basically, like, if you do represent it in binary in the CBOR, that there's these tags so that it will give you hints as far as when it's converted to JSON, it should be converted to, let's say, base 64. And I need to do the same thing for all the different encodings, including base 58. So,
I mean, that causes hash inconsistency though, because now you have binary that basically means the same thing in two different blocks, but it has this hint that says, you know, this one should be serialized.
Right. Yeah, well, this is mostly for CBOR outside of IPLD to fit the document with this lossless conversion. But I think I certainly am working on it all in IPLD, but I need to have it interoperable with everyone else's approach. So major headache.
Yeah. I think on like the JSON specification, I think we use also base 64, if I recall correctly. I can't recall.
I think we use 32 for CIDs, and then we use 64 for binary.
Oh yeah, that's right. Yeah. All right. Anything else? All right, and then thanks everyone for attending, and see you all again next week. Goodbye, everyone.
I have some PL stuff at the end here for